I am going to try our question and answer session, the sort of conceptual questions, as just a straight lecture. So the way this is going to work is that you're going to need to maybe even pause the video, but take some time to think about the question, and then we'll talk through the answer. Let's see how this works compared to that Nearpod quiz version, which doesn't seem to be working. So the question is, where is the center of mass of a baseball bat located? So we're considering, and you'll have to live with my weird drawing here, but we're considering the shape of a baseball bat being, this is awful. I'm such a bad, oh boy, being very large at one end, right? So we have the part that hits the ball, very large at one end. Oh, my drawing doesn't even show up. Very large at one end. Let's try up here. All right. This looks sort of like a turkey leg. And then it gets skinnier towards the handle end, right? It gets skinnier and less massive towards the handle end. And then there's like a little grabby part there. So this looks like a turkey leg or something. But think about the shape of a baseball bat. So where do you think the center of mass is located? Is it at the midpoint? So the midpoint would be sort of halfway between the two ends. Is it closer to the thick end, so over here, or is it closer to the thin end near the handle? Or does it depend on how heavy the bat is? Do we need more information? So pause now and think about it. The answer is that it's closer to the thick end. So this may surprise you, but more mass is located at the thick end, and only if the bat were uniform would its center of mass be in the middle. So what we mean is we could sort of model this as a really, whoops, I didn't mean to do that. We could model this as a really big ball right here connected with a massless sort of string or something to a really small ball here, right? So this would be like the thick end of the baseball bat, and this is the sort of thin end of the baseball bat. The average position of these two masses is not in the middle, right? The average position of the two masses is going to tend to be closer to the more massive section, so closer to the thick end. Center of mass is not a totally obvious concept. So if you're still confused, be patient and keep thinking about it. Okay, so now we have a disk shown in 1, and its center of mass, we're going to assume it's a uniformly distributed disk. So I was going to say like a record, but you probably don't even know what a record is. A CD, you probably don't even know what a CD is. It's just a disk, maybe of wood or metal. Center of mass is at the center, at the geometric center of the disk. So now we're going to consider cutting that disk in half and arranging the pieces as shown in picture 2. So where is the center of mass for picture 2 compared to picture 1? So does the center of mass go higher? So from the X here in the center, does it go higher? So maybe it's here. Does it go lower? So maybe it's here. Or is it the same? So center of mass still in the middle of the two? Or something else? Or no definable center of mass. So it turns out that the center of mass of each half is closer to the top of the semicircle than the bottom, right? More mass is located along the top of the semicircle than along the bottom. So the center mass of each semicircle is shown here as the 2 navy blue dots. And then the center of mass of those 2 dots is in between those two, is the middle of those 2 dots, right? Because they're equal mass, we cut it in half. So the center of mass of the system is where that red X is. The center of mass of the system is slightly above the center of mass of the whole disk. Strange, but true. And now we'll look at a calculation example, a couple of calculation examples. So I'll pause and switch to the document camera.